Hello students, today's agenda is to check homework. You're going to have a warm-up that is going to go by fast, hopefully because you have some practice with it. We're going to do or learn about the recursive formula, and you will be able to do 6.4. Today students will be able to create and interpret single-step recursive formulae. Okay, so here's the warm-up. I recommend that you pause it. These are the functions that I'm giving you, and so please find the following. Okay, so pause it right now, and that way you can get the answers, because I'm gonna go really fast giving you the answers. Okay, so this means replace this in the f of x, so it's gonna be removing the x, so it's going to be 2 times x plus 1 plus 1. And so that's equals to 2 times x, and 2 times 1 is 2x plus 2 plus 1, combine like terms, and so that's equals to 2x plus 3. Okay. So that's my first answer right here. For the next one, I need to use g, and so it's gonna be replacing the x with x plus 1, so x plus 1 plus 2. Combine like terms, and so my answer will be x plus 3. Okay, so that's the answer for question number 2. The next one is now looking at the function with h, so replace x with this, and so I remove the x and put x plus 1. Since there is nothing else that I can do, that will be my answer. h of 7, that means replace the x with 7, so it's just 7. The next one, it's 7 plus 1, which is g of 8. And so replace that in x for g. So that's going to be equals to 8 plus 2, which is equals to 10. And finally, we're looking at the function with f of x. So replace the x with x squared. So it's going to be 2 times x squared plus 1. Since there is nothing else that we can combine or simplify, we just leave it at that. Okay, so that was the warm-up. Now let's start with a scenario. Let's say that we have 2 rabbits. And then in a month, you have 8 rabbits. In 2 months, you have 32 rabbits. Then you have 128 rabbits. Okay, and then you have 512 rabbits. So what's happening in here? What's going on? Well, we can see that from here to here, I multiply by 4. Then from here to here, I multiply by 4. From here to here, I multiply by 4. And I also multiply by 4. Okay, so this is going to be very important. Okay, so later on, we're going to be finding a function, now that we're working with functions, and the function for this sequence will be f of x is equals to 2 times 4 to the x minus 1. And for now, that's a little too complex for us, okay? We're just gonna leave it aside, but later on in the future, we'll be learning about this type of functions, okay? So for now, what I want you to do is write what is called the recursive formula. And the recursive formula has two parts to it. We're going to say that we always have f of 1, which is the initial point. So it's f of 1, initial point. Okay, so f of 1 in this scenario is 2 because we start with 2 rabbits. Okay, and then we have f of n all the time. F of n is equal to n minus 1. For example, if I want to look at the second one, what did I do to the first one to get the second number? Well, I multiplied by 4. Okay, and why do I put minus 1 in here? Because if this stands for f of 1, meaning the first number, f of 2 meaning the second number in the second input, then what did I do? I look at the first one. I look at n minus 1 at the previous one, okay? And I multiply by 4. So basically, this is going to be my recursive formula. When I ask for the recursive formula, this is what I'm going to be asking for. F of 1 with the initial point, and then f of n, always n minus 1, meaning look at the previous one, and the pattern, multiply by 4. Now, there is another way of writing this, and this is just so that you know that if you see f of n is equals to 4 times, and I'm missing an f in here, is 4 times f of n minus 1. Okay? Sorry, that doesn't mean anything. Well, it means a lot. It means that look at f of n minus 1 at the previous one. Okay? So 4 times f of n minus 1, going back one space. Okay, so now what if I start with 10? All you would do is just change this, but if the pattern continues to be the same, multiplying by 4, all you do is start with 10 in here and you multiply by 4. Okay? Okay, so now we're going to go back the other way. We're going to find the recursive formula from some sequences. If I have not a scenario, but just a sequence, let's see. Okay, there is one. 5, 7, 9, 11, 13, 15, 17, and so on. So how do I write the recursive formula for this sequence? Remember that you always start with f of 1, which is my initial point. So that's the easy part to find. The next part is f of n. And my f of n is always f of n minus 1 and what do we do with the pattern? What is the patterning here? So we can see that we're adding 2, we're adding 2, we're adding 2, we're adding 2, and we're adding 2 to all of them. So it's always f of n equals f of n minus 1 and whatever we're doing with the pattern. So basically we're adding 2 to the previous one, okay? This just means look at the previous number in the list. Look at the previous number in the list, okay? Okay, let me give you some more. Okay, let's see. I have it a little disorganized, so I apologize for that. So it's going to be 12, 10, 8, 6, 4, 2, and so on. So what is the initial point? For my recursive formula, I'm going to have f of 1 equals the initial point, and the pattern. What is the pattern here? Minus 2. I'm subtracting 2 from the previous one. To find this, I subtracted 2 from the previous one. I subtract 2 from the previous one, and I subtract 2 from the previous one. So for my f of n, I will write f of n minus 1, previous one, right? For f of n, find the previous one and subtract 2. Okay? So this will be my recursive formula. Okay, so take a minute to write that. Let me give you another one. And I want you to try it before I give you the answer. Okay, so maybe pause the video so that you can try it, and that way I can give you the answer. Okay, again, remember that the first thing you need to know is the initial point, and also what is going on each time. So I'm multiplying by 2, I'm multiplying by 2, I'm multiplying by 2, multiplying by 2, multiplying by 2. And so I always put f of 1 equals my initial point. I always put f of n is equals to f of n minus 1. And what am I doing to the previous one? This means the previous in the list, right? What am I doing to it? Multiplying it by 2. Now, if you write it this way, that's fine. But remember that sometimes you will see it with these two right here. And both are correct. So it's f of 1 equals 1. And f of n is equals to, we multiply by 2 the previous one. Okay, all I'm doing is moving the 2 before or to the left of my previous one. Now, what if they give me the recursive formula and I have to find the list, okay, the sequence? Okay, it might say something like this: find the first 4 terms. And I'm going to show you the long way and also show you the fast way so that you can choose which method to use, and so that you can also understand what it means. Okay, so if I have f of 1 equals 3 and f of n equals f of n minus 1 plus 4, okay, so this means that I have f of 1 equals 3. How do I find f of 2? Well, I'm going to replace it in here just like we did in previous, or even for the warm-up. Okay, I'm going to do my listing here. So it's going to be f of, instead of f of n, it's going to be f of 2 equals f of 2 minus 1, right? We are replacing the n with a 2 plus 4. This is f of 2 minus 1 is 1 plus 4. So this means, in here it says, look at the first one in the list, right? F of 1 is 3, so I replace it with 3 plus 4, which is the pattern, right? That's equals to 7. So f of 2 is 7. Okay? I'm gonna go kind of slow in here because I don't want to lose you, to make sure that you follow me. Now I'm gonna find f of 3. Again, f of 3 means replace the 3 in the n. So f of 3 minus 1 plus 4, which is f of 3 minus 1 is 2 plus 4. But f of 2 doesn't mean number 2. It means go to the function of 2 to see its value and replace it in here. So f of 2 is 7, so I'm going to replace it in here. Instead of that, it's going to be 7 plus 4. Basically, to find f of 3, he says, look at the previous one and add 4 more. Okay, so that's equals to 11. So my f of 3 is equals to 11. F of 4, how do I find f of 4? Well, I replace it in here. F of 4 minus 1, it means look at the previous one and add 4 more. And so f of 4 minus 1, he says look at f of 3 and add 4 more. So f of 3 is 11, so I'm going to replace 11 in here plus 4 more. That's going to be equals to 15. Okay, and I think it says to find the first 4 terms, but I think I want to go one more just so that we really get this concept. So to find f of 5, f of 5 means look at f of 5 minus 1, meaning look at f of 4 plus 4 more, because that's the pattern. And so look at f of 4 plus 4 more. And what is f of 4? It's 15. So I replace f of 4 with 15 and add 4 more. That makes it 19. Okay, so that's how you use recursive formulas to find the list. If you want to do the process, or if your teacher asks for you to show all the work, that's how you would use it. However, if you know, and let me use this blue color, if you know that this is your initial point, that means that's the first number in your list, the first term. And then it says look at the previous, right? This means look at the previous term, at the previous one, and add 4. So for the second one, look at the previous one and add 4. That will be 7. There you go. For number 3, look at the second one and add 4. That will be 11. For the fourth one, look at the previous one. That's what f of n minus 1 mean, and add 4 more, so that's 15. And for number 5, look at the previous one and add 4 more. That will be 19. Okay, take a minute to write that down. Pause it if you need more time. I'm sorry, sometimes I feel like I'm going too slow. Other times students tell me I'm going too fast. So hopefully I'm not going too fast in here. Okay, let's do g of 1 is equals to 3. And then we're going to do g of n is equals to 4 g of n minus 1. So don't get scared just because I changed the g. It just stands for, it's the same thing. I'm just using it to differentiate from the previous function, but it's exactly the same. Let me do it the fast way first. This means that I'm multiplying the previous one times 4. So the first one in the list is 3. It says for the second one, look at the previous one, multiply by 4, and so it's going to be 12. Look at the previous one and times 4, that will be 48. Times 4, right? We'll look at the previous one, times 4. That one I do have to do because I don't know it by memory. So 4 times 8 is 32, carry 3. 4 times 4 is 16, and 3 is 192. And it's asking only for 4, so we'll leave it at that. And if you want to show the work, f of 1 is 3, because they are giving it to you. F of 1, I'm sorry. G of 1 is 3. G of 2, so it says G of 2 is equals to 4 multiplied by G of 2 minus 1, which is 4 times G of 2 minus 1 is 1, meaning replace that in here. And so it's going to be 4 times 3, which is 12, right there. Okay, and let's put the 12 in here. For G of 3, we're replacing the n, so it's 4 times G of 3 minus 1, meaning look at the number 2. At the second one, 4 times G of 2, see, G of 2 in the list. And so it says replace G of 2 from G of 2. Okay, the answer of G of 2. So it's 4 times 12, which is equals to 48. So G of 3 is equals to 48. And then G of 4, right? To find G of 4 is equals to 4 times G of 4 minus 1. So it's 4 times G of 3, right? Look at the previous one, at number 3. And so in here, I'm going to replace it with G of 3. And so it's going to be 4 multiplied by 48. And it's 192. Okay? Again, this is if you want to show your work, but if you, on the assignment, you want to go directly, I will understand that you get it. And that's it for this assignment. So have fun working on 6.4. And sorry about, I was looking for some material. Sorry about those times that I kind of stopped.